everybody. Today I'm going to talk about object-oriented programming. Object-oriented programming is basically some kind of like more way of coding, the way you code, but it's like putting everything in object. Before we used to kind of like implement procedural programming languages. Like let's say if you declare, like you would have to declare every variable. Everything was variable. But now, like after that we came with the struct, right? So with the struct, like there was some kind of basically structure, and we used to use that to point it to some variable, and it was some kind of chunk in memory that would correspond to some variable. But these days we use object-oriented programming. In object-oriented programming, when you create a new object, it creates some corresponding memory. It creates some memory in RAM, and after that, like this way, you could probably you don't have to declare all those variables. You have to declare some kind of structure. Like classes are basically some kind of structure, and you could have multiple instances of those structure. With structure, like you could implement like method inside the structure, but with classes, now you can define methods, let's say. But with this object-oriented programming, we are considering everything in the real world to be object, and they can correspond to the object in code. That means like for everything you see, you can create a class. Basically, let's first try to focus on the importance of object-oriented programming. Let's say if you're using a code and you're using a structure, then you would only be using like structure or variables for that base only. Let's say if you're creating a class in a different file, then later on you could just take a reference to that file and make and can access that object every time. This way you could use that object anywhere you want. These are the basic facts. After that, the main thing is inheritance with the object. Actually, like after the invention of object, we thought like, okay, we're gonna create some structure. Why kind of like repeat? Let's say if there's a graduate student and if there's an undergraduate student, right, they would have similar type of data, but like why kind of like do a lot of these kind of redundancies in the data? So we thought, okay, we're gonna kind of like create some kind of hierarchy so that the class can follow, and this is basically called on inheritance. Let's say if you have a class-based student, right, and undergraduate student and graduate student would have their additional data or property or methods in addition to that from the superclass, that is like the student, and now they could have used those properties, inherit those properties, right? So you don't have to kind of like write that code every time, or even in memory you don't have to kind of like create a lot of consume a lot of memory. Actually, you should be good at telling bad thing and good thing about object-oriented programming. Right? What I think is like basically using procedural language. What my focus was, okay, let's say if I'm using an int, I would just use 4 bytes. But like now, if I'm using a class byte, I would consume like 60 bytes. Just compare 4 and 60 bytes. That's like memory, consuming memory. But since we have a lot of memory, so we don't worry about those kind of memory. But if you are running a large applications, right? If you want to design some kind of large application, you could do some kind of cutoff on that one. You could probably think it that way. More about like polymorphism, right? Polymorphism is basically same thing but different work. Like let's say if you have some kind of methods, right? Same name, same methods, right? But it does like there's a way to reach both of the method, right? and they're different. Like let's say constructor overloading, that's one of the polymorphism like that .NET provides, right? And parametric polymorphism is something that it works with others too. Let's say if you have a string, if I want to print int as a string, because we know that strings are only the ones that gets printed, but even if you print int, it works. That's like parametric polymorphism. Now we talked about it, and the abstraction. Abstraction is a way where we hide the details of implementation and just provide some kind of interface, low level details, basic details to the color methods. Let's say if you are designing something, you probably want to create an interface so that you can pass that raw interface to the other class, so they can use that, instead of getting the all details of your class. Now let me talk more about object-oriented programming and how is it useful, but that'll be in next chapter. Let's wait till then.